So in last lecture, we have discussed a concept of strain energy, first of all. Okay, in last lecture, we have discussed concept of strain energy. What is the resilience? What is the proof resilience? And what is the modulus of resilience? Okay, so now, whenever any body, uh, 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 now on a particular body, there are different kind of load supposed to be act. Okay, so that loads or that force, maybe we can say as an action. So basically action may be divided in two parts. Say one part is the force and another part is the moment. Is it clear? Whatever the action will be applied on a applied on a body, it may be basically divided into two parts. That is the force or moment. Right now. So now again force may be a action may be divided in two parts. One is the force and another is the moment. Now your force may be an internal force or external force. So in case of the internal force, in the case of the internal forces or internal actions, okay, internal forces or internal action, we can divide that internal action into a four different part. That is your axial force, that is your shear force, that is your bending moment, and that is your torsion moment. Yes or no? Please confirm me, students. Torsion moment, that is also known as a torque. That is also known as a twist, turning moment. All are same. Fine. So your body may be subjected to this kind of the actions. Fine. Na? Chaliye. Before starting today's major topic, let me discuss different condition under which we are supposed to derive what is a changes in a stress level under on a body. Say your body is subjected to, first of all, gradual applied load. Gradually applied load. Second case is a suddenly applied load. And third case is the impact load. Now, before starting the each and every derivation, let me first of all understand what is a gradual applied load, what is suddenly applied load, and what is the impact load. And now, if we are applying the gradual load, or if we are applying the sudden load, or we are applying the impact kind load, what is the behavior on a body? So whenever we are applying a load gradual, that means, for an example, we have to apply in all three cases. We have to apply in all three cases same load, say 100 kilonewton. Okay, we are interested to apply 100 kilonewton load in all three loading conditions. Your body is same, body having a same dimension. Okay, say diameter will be same, say length will be the same. So in that case, what is the gradual load? First of all, gradual load is nothing but we will apply set by set load, 1 kilonewton, 2 kilonewton, 3 kilonewton, 4 kilonewton, 5 kilonewton, up to 100 kilonewton load we will apply one by one. Okay, now as the application of such kind of loading, you are applying the load on body. Due to application of load, there will be some deformation in your body, yes or no? And that deformation also in linear manner for a gradually applied load. Is it clear or not? Please confirm me. This is load versus deformation diagram. This is a case of the gradually applied load. Now, second case is your suddenly applied load. Now, what is a suddenly applied load? Now what we can do, we can bunch, or we can put all together this 100 kilonewton load and apply that load on a body at a time. That a load is known as a suddenly applied load. We will apply load in a single time. Now, as the application of such a load, we are supposed to apply load at a single time. Okay, due to application of load, we can say that deformation will be occur at a time. Deformation on a body will be occurred at a single time, yes or no? Is it clear? Is it clear? So this is the case of the suddenly applied load. So again, this is your load versus deformation diagram. We will discuss it is in a very detail later on, don't worry. Okay, and similarly impact kind load. Now let's say 100 kilonewton load. That 100 kilonewton load will fall on a body from say 3-meter height. Such kind of load is basically known as the impact load. Is it clear? Is it clear? I hope which kind of loading is known as a gradual apply load, which kind of loading is known as a suddenly apply load, and which kind of loading is known as a impact loading. Now, as we have discussed in a previous lecture, strain energy. Strain energy is nothing but work done or energy absorbed due to the application of load. ऐसा कुछ discuss किया था. Fine. So whenever we are apply the load on a body, now type in chat box only. Is there any difference in a registering pattern? Registering pattern will different or will remain same? Type in chat box only. Is there any difference in a registering pattern? Yes or no? Same body है. सोच के आंसर दीजिए. Is there any change in a registering pattern? चलिए बताइए. Okay, good. Why no change? चलिए आंसर दीजिए. क्यों चेंज नहीं होगा? No change is a right answer. I will explain, don't worry. Why no change? Registering pattern, that means resistance versus deformation diagram. Resistance versus deformation diagram. Why no change? My question is that. So now just simple understand, whatever kind of the body is there, on a body, whatever kind of load will be applied, either it is a gradual load, or it will be a sudden load, or it will be an impact load. Your body doesn't able to understand which kind of load is applied on this. Yes or no? Yes or no? So as a application of load, your body will start deform or will start absorbing the energy. Yes or no? Yes or no? So your resistance versus deformation diagram will remain linearly, okay, up to elastic limit, because we are considering the elastic limit condition. Is it clear or not? इतना clear है? इतना clear है? Students? Okay, I hope it is clear to all of you. Okay, your body को पता नहीं है कि कौन से टाइप का लोड आ रहा है, है ना? Body will behave once the load is applied, but that behavior, that means change in a length or development of the internal resistance will be a linearly vary. Right? So chaliye, we will derive first equation. We are going to derive first equation, that is a gradually applied load. Now we are today we are going to derive two important equations: stresses in a prismatic but subjected to gradual applied load, and stresses in a prismatic but subjected to suddenly applied. Okay. Stresses in prismatic but subjected to gradually applied loads. Okay, for that purpose, Again, this is your first case. We are interested to determine or to know which kind of the stress is developed if your body is subjected to gradually applied load. Let us consider a prismatic bar. You can consider horizontal or you can consider vertical, doesn't mean. Okay, let us consider prismatic bar having a length L. Let us consider prismatic bar having the length L, and it is subjected to axially applied load P, and which is a gradually applied. Is it clear? Is it clear? Itna clear hai? Okay, so I am writing here also. Consider a bar. Consider bar having length L. Length equals to L. Now the material having now bar your body is made of the some of the material, and all the material having a sum of the modulus of elasticity. Say modulus of elasticity that should be equals to E. Now if we are applying the load, applied a load, that should be equals to P. That is a gradual load. Okay, cross sectional area that should be equals to A. Cross sectional area ये prismatic bar का A है. And deformation. Now if we are apply the load, whenever we are apply the load, your body will start to deform. Whenever we are applying the load gradually, what will be happen in your body? What will happen in your body? Suppose I am apply load at this amount, up to P amount, right? So I am applying load up to the P amount. Now this P amount load is divided in a different part because I am applying load in a gradual manner. Okay, धीरे धीरे load apply कर रहा हूँ. So your deformation will be also occur in your body will be linearly with respect to load. Yes or no? Yes or no? Your deformation in your body also linearly in your body. Yes or no? So this is a maximum load P we have applied. Corresponding deformation, that is a delta. This is a deformation versus load diagram. This is a deformation versus load diagram. Okay, fine. I hope it is clear to all of you. Chaliye. Next, as apply gradual load and draw load versus deformation diagram, which is already I have plot. Okay, so I am writing here. This is your load versus deformation diagram. Okay, this is your load versus deformation diagram. So now, what is work done? Okay, first of all, we are interested to find out work done. So whenever I am applying the load, your body will deform like this. So work done equals to, I think we have already covered in last lecture, and all of you are learned at your physics level. Work done equals to area under P delta curve. Yes or no? Area under P delta diagram. Area under P delta diagram. That is nothing but it is clearly seen that this diagram is a triangular in nature. Yes or no? This diagram is triangular in nature. Yes or no? Yes or no? So your work done equals to 1/2 P into delta. I hope it is clear to all of you. Equation number 1. Students, please confirm me. Is it clear? Chaliye, next. Now, whenever we apply gradually load on a body, we'll show some resistance. Yes or no? Whenever we apply gradual load on a body, it will show some resistance. That means your material or body will start deform. Okay, up to the and up to the elastic limit. So now this deformation pattern is also a same. Okay, this deformation pattern is also a same. So now whatever delta observed under a externally applied load, same delta will observe due to resistance. Is it clear? Because we are considering the elastic limit. Same deformation considered under a resistance. So for same deformation, suppose we have observed resistance R. Is it clear or not? Please confirm me, students. This is your resistance. This is your deformation. So this is your R delta curve or resistance versus deformation curve. Is it clear? So now again, what is the area of this curve? It is also a triangle one. It is also a triangle one. So strain energy that is nothing but area of the R delta diagram. Okay, strain energy that is nothing but area of the R delta diagram. I hope it is clear. Or what you can say, amount of the energy stored or absorbed in a body, or what you can say, amount of energy stored or absorbed in body. Okay, that is nothing but strain energy. We have already discussed. And what amount of energy stored or absorbed, that is nothing but, now just simple understand here, we have applied gradual load amount P. Due to application of gradually applied load, your body deform up to delta. Now this strain energy is nothing but amount of energy stored or absorbed in a body, that is due to the resisting capacity, its resisting capacity. So to for that purpose, your body will deform, your resistance will be up to same deformation. ठीक है, आपका deformation same ही रहेगा. So that is nothing but 1/2 R into delta. I hope it is clear to all of you. Okay, so now as per energy conservation law, as per law of the energy conservation, as per law of energy conservation, what we can say, whatever work done on the body, that is nothing but that is equals to amount of energy stored in a body. Yes or no? Whatever work done on body, that must be equals to amount of strain energy or amount of the energy stored or absorbed of the body. So this is your equation number 2. Just compare equation number 1 and equation number 2. What we will get right here. So we can write here work done equals to, work done that should be equals to amount of energy stored in body. Amount of energy stored in body. We have already calculated work done, that is 1/2 P delta. Put here. We have already calculated amount of energy stored in body, that is 1/2 R delta. Put that value. Delta. So we can say here R is P equals to R. So now what is the meaning of this P equals to R? Let me understand. So now actually we are not interested to calculate P equals to R, but but we are interested to know what is the stress level developed due to a gradual applied load. Is it clear? We are interested to know what is the stress level due to gradually applied load. Now, just simple understand, whatever kind of the load I will apply or we will apply on a body, we are not able to calculate how many or how much resistance will develop. Yes or no? But we can derive relation between applied load and resistance. Yes or no? Yes or no? We are not able to know how much resistance occurred, but actually from the mathematical relations, we actually know what is the relation between a applied load and resistance. So from that, we are able to know what is the stress developed under a body. Now we have already know that what is the stress, internal resistance per unit of cross-sectional area. So your resistance is R. Keep in mind, I am not considering P. P is your externally applied load and R is the resistance. And I have lots many times say to all of you, your stress is nothing but internal resisting force per unit of cross-sectional area. So don't mix up here. So R by A. So as we know, what is your R? R equals to P. So in this case, your stress equals to force by. I hope it is clear to all of you. So for a gradually applied load, your applied load and resistance will become same. For a gradually applied load, your applied load and resistance will become same. So now we have already derived equation of strain energy U, that is equals to sigma square by 2E into volume. So for I am writing here UG, that means strain energy under gradual condition. Okay, UG, that means strain energy under gradual load condition. That should be equals to, we have put up the value, we have already calculated value of stress, put value of the stress here. Okay, so stress equals to P by, so we can write here P square by 2A square E. It is not required to derive such equation, but just for understanding the relation between if we are applying the load in a sudden case and if we are applying load in a gradual case, what will be a change in a strain energy and stress level. That's the reason I am writing this equation here. And volume equals to, we can write here area into length. Yes or no? So now we can again simplify it. Just consider sigma. Okay, I am not considering P by sigma square by 2E into volume. Normalize આવશે because your force equals to P છે. Okay, ચલો આને મૂકી રાખો, આને equation number star લખી રાખો. Okay, this is for a gradual loading. Now what we can do, we are going to derive same condition for sudden loading. Okay, we are going to derive same condition for sudden loading. So you people able to know what is the what happened under a sudden loading and what happened under the gradual loading. So stress of prismatic bar subjected to sudden applied load. Stress in prismatic bar subjected to sudden applied load. Okay, your body is subjected to suddenly applied load. Now all people know what is a sudden load. Okay, so same body will consider, same cross sectional area will be considered, same amount of load, axially load applied, but it is applied suddenly. Is it clear? Same amount load is applied, but it is axially. Fine na? Fine na? इतना clear है? So now, as the application of sudden load, first of all, same procedure will be followed. We are going to plot load versus deformation diagram. Now, tell me, we are going to apply load suddenly. That means we are at this point directly. Yes or no? This is your load versus deformation diagram. Load P versus deformation diagram. Yes or no? Please confirm me. We are at this point directly. Yes or no? But in previous case, we have applied load at several locations. Gradually, we have applied load and reach at this location or at reach amount of P. Yes or no? Itna clear है ना students? Please confirm in chat box. Okay, so fine. In this case, if we are applying the sudden load, your body will deform suddenly. Your body will deform suddenly. Yes or no? This is externally applied load. No? This is not an internal. This is not any internal connection. Your body will deform suddenly like this up to delta amount, up to delta amount. Yes or no? So in this case, your load versus deformation diagram looks like this. Everybody with me? Yes or no? Your load versus deformation diagram looks like this. Itna clear hai? But as a application of load, there should be some resistance develop in your body. Now, as we have discussed, whatever kind of the load will be applied, on body, your resistance will occur linearly only. Yes or no? Yes or no? Your resistance of the body will be linearly and having a same amount of delta. Keep in mind, having a same amount of delta. I hope it is clear to all of you. Fine. So this is your delta and this is your resistance R. So again, this is your, I am writing here P versus delta diagram. And this is resistance versus delta or deformation diagram. You can write delta L also. Okay. So this is your resistance. And this is your deformation. I hope it is clear to all of you. Itna clear hai? So in this case, your resistance versus deformation diagram having a triangular area. Fine na? Chaliye. Next. Same procedure. Amount of work done on body. Amount of work done on body. That should be equals to area of P delta diagram. So that should be equals to P into delta directly. P into delta. Equation number one. Now second, similarly, we are going to calculate strain energy. Fine now, we are going to calculate strain energy. That is nothing but amount of the energy stored or absorbed in a body. Okay, strain energy. That should be equals to amount of energy stored or absorbed in body, and that should be equals to area of R delta diagram. Area of R delta diagram. That is nothing but it is remain triangle. Keep in mind 1/2 R into delta. Equation number 2. Apply same condition which you have applied in previous case as per conservation law of energy. Just see here. I am not writing again here. Just see here. As per As per law of the energy conservation, work done equals to amount of the energy stored in body. So we can write here, work done equals to that should be equals to amount of strain energy stored, amount of energy stored in body. Okay, so we have already calculated work, that is P into delta, that should be equals to 1 by 2 R into delta. So in this case, we will get resistance R equals to twice P. Is there something difference in this case? Yes or no? Is there something difference in this case? Yes or no? कुछ तो difference निकला. चलिए. Again comes back to definition of stress. Stress equals to resistance, internal resistance by unit of cross sectional area. Okay. So in this case, R equals to 2P by A. This is the case of the sudden applied load. Sigma is, that means suddenly applied load. And I am writing here sigma gradual. That means gradually applied load, sigma G. So I am writing same equation here. What is the sigma G, gradual applied load? P by A. So we can conclude from these two equations, your stress developed under suddenly applied load, that is the twice of the gradually applied load. Yes or no? Yes or no? Yes or no? Stress developed under suddenly applied load. Stress developed under suddenly applied load. That is the twice of the gradual applied load. So what we can say here, sigma S equals to, what is P by A? P by A is nothing but sigma G. P by A is nothing but sigma G. So we can write twice sigma G. I hope it is clear to all of you. I hope it is clear to all of you. Clear है? तो स्ट्रेस ट्वाइस डेवलप होगा. चलिए, we have one more equation, strain energy, that is equals to sigma square by 2E into volume. Put value of the stress for suddenly applied load. So we can say strain energy under suddenly applied load. What is your load? Twice, yes or no? Twice load hai. Put same value. Twice, that means 4P square divided by 2A square E. Is it clear? Is it clear? Into volume. Into volume. Now, just simplify. Strain energy under suddenly applied load, that should be equals to, don't evaluate it. P square by A square, that is nothing but sigma square, for sigma square divided by 2E into volume. Yes or no? Please confirm me. Yes or no? ऐसा कुछ लग सकता है. इक्वेशन नंबर से ए. ओके, ये हमने सडन केस के लिए लिखा है. नाउ सेम इक्वेशन विल राइट फॉर ग्रेजुअल कंडीशन. सो sigma equal to sigma square, sorry, strain energy U equal to sigma square by 2E into volume. So now for a strain energy under gradual condition, load is P by A. Yes or no? Put that value. U equals to, under gradual loading condition, P square by 2A square E into V. Yes or no? So now just now we can say that P square by A square, again sigma square, UG equals to sigma square by 2 E into volume. Just put this value, sigma square by 2 E into volume. Sigma square by 2 into volume here. Sigma square by 2 into volume, that is nothing but strain energy under gradual condition. Yes or no? Strain energy under gradual condition. So what we can say, strain energy occurred under a gradual, under a sudden condition, that is the 4 times that of the gradual condition. Is it clear? Is it clear? ऐसे डेरिवेशन पूछते हैं. You are able to derive this, right? इतना क्लियर है? प्लीज कंफर्म मी. Again we are concluding same theory. First conclusion is this. Second conclusion is this. Your stress for a suddenly applied load, that is a twice as compared to gradual applied load. Clear? Your stress for suddenly applied load, that is a twice of the gradual applied load, and strain energy for a suddenly applied load, that should be 4 times the gradual applied load. That's it. Now from this what we can say, chaliye, suppose we are going to apply 3 different kind of load. First is the gradual applied load, having a same amount as we have discussed. Second is a suddenly applied load, same amount. And third is the impact load, which is the fall from some height, having a same amount. Okay, so now this is the case number A, this is a case number B, and this is a case number C. Case number A is a gradual, case number B is a sudden, and case number D is a impact. So whenever we are going to apply gradually load, your deformation, there is some amount of the deformation. So I am writing here delta L gradual. Okay, if we are going to apply sudden load, in that case there should be some deformation, that is a delta L sudden. And if we are going to apply the impact load, in that case some deformation, delta L impact. Now type in chat box only in which case maximum deformation will be occurred. In which case maximum deformation will be occurred. मेरे को असेंडिंग डिसेंडिंग फॉर्म में लिख के दीजिए. फॉर एन एग्जांपल A, B, C और C, B, A ऐसे लिख के दीजिए. चलिए फर्स्ट वाला आंसर सही है, सेकंड वाला आंसर सही है, मैंने ऑप्शन लिख दिया है. यस देव, यू आर राइट. ओके, जस्ट थिंक if I am applying the load gradually on body, okay, we are going to apply same load, say 1000 kilonewton same load में apply कर रहा हूँ. okay, so 1000 kilonewton का लोड में स्टेज बाय स्टेज अप्लाई कर रहा हूँ, ग्रेजुअली अप्लाई कर रहा हूँ. ये आपका डिफॉर्मेशन यहाँ तक आएगा. सेम 1000 kilonewton का लोड में सडनली अप्लाई कर रहा हूँ, तो जस्ट थिंक your deformation must be a more than as of the gradual one in case of the sudden. But in case of the impact, you are we are applying the load from a height. Okay, we are falling from some height. In that case, again your deformation is more than sudden. Is it clear? Is it clear? So from that we can also conclude that with respect to gradual and sudden, in a suddenly applied load, your body will fail earlier. Okay, or break earlier. Is it clear? इतना clear है? I hope it is clear to all of you. If you want to take a snapshot of slide, you can take a snapshot. This is first one. Second slide. Third slide. Fourth slide. Fifth slide. Yes, the recording will be available. Don't worry. Okay. I hope it is clear to all of you.